On the screen, we have 5x minus 2 and 6x plus 2. So these two are linear polynomials and they are not equal. Why they are not equal? Because on the left side we have 5x, but on the right side you have 6x, and so they are not equal. Also, the constant on the left, it is minus 2, but the constant on the right, it is plus 2, and they are not equal. Therefore, the two polynomials are not equal. But whenever we have two linear polynomials which are not equal, we can always make them to be equal by finding out two constants. Like in this case, we have 5 upon 6 and minus 11 upon 3. Inserting these constants with their signs, we can make the two linear polynomials to be equal. This is a fact. It is always possible, and you can check that this is actually very, very true. So we have to find the integral of 5x minus 2 upon 1 plus twice of x plus 3 times x square dx. And here, when you look carefully, you will find that the numerator is a polynomial of degree 1, while the denominator, you have a polynomial which is of degree 2. But if we differentiate only the denominator with respect to x, then you'll be getting a polynomial of degree 1. So knowing this fact that a polynomial of degree 2, when you differentiate with respect to x, you get a polynomial of degree 1, then applying the same fact we discussed earlier, we can write down 5x minus 2 is equal to a times the derivative of the denominator of the given integrand with respect to x plus b. And you'll be getting a times 6x plus 2 plus b. So on both the sides, you are having two linear polynomials, and they can be made to be equal by inserting two constants. So we say constants a and b. And when we do that and compare the like powers of x and the constants, we can express 5x minus 2 as 5x minus 2 equal to 5 upon 6 times 6x plus 2 plus minus 11 upon 3. So what we are doing here is we are expressing the numerator in terms of the derivative of the denominator and making them equal by inserting two constants. So the numerator of the integrand 5x minus 2 can be expressed as the derivative of the denominator as 5 upon 6, 6x plus 2 plus minus 11 upon 3 upon 1 plus twice of x plus 3x squared dx. And split the integrals into two integrals. And as we know, the constants are not affecting the integrals, so we take the constants out from the integral and solve the two integrals separately as I1 and I2. And after getting I1 and I2, then we substitute those values and get the final answer. I1 can be solved by using the method of substitution, and in this case we take the whole denominator equal to t, and t is on the right side, remember, and applying the same theory which we discussed earlier in integration by substitution, then this integral can be simplified and get the answer. I2 can be solved by first transforming the denominator into the form of x squared plus a squared, and after we have done that, then we integrate using the standard formula. So the denominator can now be written as 3 times x plus 1 upon 3 whole thing square plus root over 2 by 3 whole thing square, and this is in the form of a standard formula which you can easily apply. Now after getting I1 and I2, we substitute in the main equation, and the two sets of constants of integration C1 and C2 are added together or subtracted as needed, and put only a common constant of integration, capital C, and to show that there is only one constant. So that is all about this problem.